Hey guys, welcome back. 4.2. Position, velocity, and acceleration. We have this cute little alcohol and calculus don't mix. Never drink and derive. Once again, like literally everything else in calculus, this is all based on derivatives. So yeah. Okay, let's get into this one. All right, so basically, first thing we have position. Position is shown. The function is s of t, which we see right here, guys. And I'm gonna draw this out for you because it kind of helps my brain. All right, there you go. And we know with what's it called? We know that with a words a parabola like this, we know it's gonna be negative. Let's say random number. Nothing here is right. Negative 6.3 t squared dot. You get it, plus 16 plus 3, whatever it's going to be. All right. Okay, so there's position. And so then now we have velocity. All right. And velocity, which are here, or no, it's not here, but velocity equals rate of change of position, which is basically the same thing that velocity or v of t equals s prime of t. All right. Velocity is the derivative of position. All right. Rate of change of position, derivative of position. Because remember, derivative is a rate of change, rate of change is a slope. And which is why the line, when you draw it out, would look similar to this. Because if you think about it, once you do our lovely little power roll to the 6.3 times 2, you get, I don't know what 6.3 times 2 is off the top of my head. 6.3 times 2 is 12.6. You get 12.6t as your as your new rate of change or slope kind of there. So there's that. So velocity is the derivative of position. And acceleration, which is even better, is also the derivative of, oh, that's wrong, is the derivative of velocity, or you can think about it as the second derivative of position of t. All right, guys, which is pretty cool. And speed is just velocity. However, of course, absolute value, because you can't have a negative speed. It just sadly doesn't work like that. All right. And acceleration to graph would literally be a straight line, because once, let me get yellow. It'd be kind of somewhere something like that, because once you take the derivative of that again, you're just left with the number, which would just be the 12.6 from before. So yeah, that's kind of that. And something to note here on the little take note. If velocity and acceleration have the same sign, it can be both positives or both negatives, it is speeding up. If there are different signs, they put negative, but that's definitely not right. If there are different signs, it is slowing down. Slowing down, all right? And another thing I have here, when the velocity is less than 0, the particle is moving left, down, west, south. If the velocity is greater than 0, then it's moving up, right, up, right, east, or north. And if the velocity is 0, that means the particle is at rest, because that means the derivative is 0. Basically, there is no rate of change at that point. So that particle is going to be at rest there. So yeah. All right, now we are moving on to our lovely example. So here we have S of t, and we know that S of t is position. And so it says where a particle moves along a line so that its position at any time greater than 0 is given by the function here, where s is measured in meters and t is measured in seconds. It says find the instantaneous velocity at any time t. So once again, we're gonna let's use what color do we use for velocity? I think it was blue. All right, so velocity. Remember, velocity or v, too thick. V of t is equal to s prime of t. So basically, we need to take the derivative of this position equation here, and that's going to be 3. So once we do that, 3/3 is just 1. So it's going to be t v of t. V of t equals t squared minus 6 to plus 8. Just so you know, we just used our constant rule for the 8t. Or no, we used a constant rule for the 5, and then we used power rule for the remaining terms there. So that is our lovely little thing here. There's velocity. And now find the acceleration of the particle at any time t. Remember that acceleration is literally just equal to the derivative of velocity, which we have found above. So we're just deriving, that's supposed to be t. We're just basically deriving this again. So a of t is equal to 2t minus 6. And that gives you your acceleration of a particle. All right, so when is a particle at rest? Remember, we said that for a particle to be at rest, let's go thread, for a particle to be at rest, v of t has to equal 0. And we are here, so basically what we do, we take the derivative of the position equation, or of the position again, which we already have. We know that v of t equals t squared minus 6t plus 8. And you would basically just set this equal to 0. Of course, we do a little factoring thing here. That would give me t minus 4 and t minus 2. Yeah. Equals 0. And once we set both of those equal to 0, we find that the particle is at rest at, guys, pretend they're at signs, at t equals 2 and t equals 4 seconds. That's when we know our particle is at rest. Now, what is displacement of the particle for the first 3 seconds? This is kind of a new concept here, displacement. And the little formula here basically is the final position, or S of B, minus SA, initial position. So basically our initial position is going to be 0, because that's where we're starting off at for this. So we're gonna basically plug in 0 into the original, or you plug in the 0 into the original position equation. And so once you have S of t equals 1 to the third times 0 to the third, or minus 3, 0 squared plus 8, 0 minus 5, you're left with S of 0 equals negative 5. All right, and you're basically doing the same thing because it wants the particle at 3 seconds, or the displacement for the first 3 seconds. We're going from 0 to 3, and so we do the same thing, but we do that for the number 3 now, which we'll do in red. So S of 3 equals 9 minus 20 plus 4 plus 24. Yeah. Minus 5. And that basically gives you, all of this gives you 1. All right. So based again on this displacement formula here, S of B minus S of A, we will have, and we'll go back to black so y'all can actually see this time, preferably. We'll just pretend this isn't here. We're going to do the math down here. So we will have S of B minus S of A equals displacement, and basically that is S of 3 minus S of 0, which we solved for up here, guys. Same thing as saying 1 minus negative 5. Keep change from just algebra 1, kids, and your displacement for the particle for the first 3 seconds will be at 6. Don't forget your unit, 6 meters. All right, that's all for, whatever this was. Position, velocity, and acceleration, unit 4.2. Yeah, thank you.